Okay, one of your objectives is learning how to use a solubility table for double displacement reactions in order to predict what the states of matter of your products are. We really are trying to find which of these products is your precipitate. Your precipitate is the solid product, and we're going to get to that in a second. So, when we use a solubility table, what we're doing is we're looking for ionic compounds in water. So all of my products here are metals with nonmetals. They're ionic compounds, plus minuses. The way that we read our solubility table is the following. If you look at the anion of each of these pairs, the second part, the negative part of each one of those compounds, if you find the anion in this area that says soluble, what soluble means is it dissolves in water. Ionic compounds are solids, but if you have water present, sometimes they dissolve. So if your ionic compound has one of these anions, it's in the section that says soluble, you're going to label it AQ for aqueous. The only time you're not going to label it aqueous is if it's an exception to this area. If you see that your anion has one of these exceptions that are listed, then this undoes the aqueous. Instead, if it is an exception, you would write a solid there. Now, the same thing goes if you find your anion in this bottom section. The bottom section reads insoluble. Insoluble means nope, doesn't dissolve. So if it doesn't dissolve, we would call it, therefore, solids. The only time we're not going to call it solids is if it's an exception that will undo the solid. And instead of writing solid, if it's an exception, you're going to say, no, it actually does dissolve this time, so it's aqueous. Let's do some examples. So I have 4 examples written here. We have aqueous solutions being mixed. We have ionic compounds being made. Ionics are very strong compounds. They should be solids, except sometimes they dissolve. And that's when you use your solubility table. So for each one of these, I'm going to look at the negative ion. So I have H, and then I have the second part. The second part here is nitrate of this one. If I go find my nitrates, NO3 minus, NO3 minus is in the soluble aqueous section. I'm going to write AQ unless I have an exception. So I'm going to write AQ. Exceptions? No exceptions. So I write AQ. Now let's look at your second one. Silver chloride. The negative part of this, the anion of this is Cl. If I go find my Cl minus here, it should be in the aqueous section. I should be able to write AQ, but we better check if there's an exception. So chlorides, you won't write AQ if you're an exception, you have a compound that has silver in it. I do have silver, lead, or mercury. So since I have an exception here, I wouldn't write the normal AQ, I would write solid. Now, if I ask you to tell me which one of these is the precipitate, you mix liquids together, you get a solid. The solid is the precipitate. So this compound right here is your precipitate. Let's go ahead and do some more examples. So let's look at example number 2. 2 aqueous ionic solutions are mixed. We get 2 new solutions that have ionic compounds, metals and nonmetals, or polyatomic ions. To find their state of matter, look at your anion. For the first step, my anion is NO3. NO3 here in this compound has a negative charge. I go find NO3. NO3 is in the aqueous section. NO3 has no exceptions. So I write AQ, aqueous. Then I go find my second anion. My second anion coppers my metal. This is my polyatomic ion. That's my anion. I go find hydroxides. Hydroxides are in the solid, insoluble section, unless your hydroxide is paired with an alkali metal Nope, it's paired with copper. It's paired with calcium? No. Strontium? No. Barium? No. So I don't have an exception. Since I don't have an exception, I write solid. Now, out of the two of those, who's the precipitate? The precipitate is the solid one. So you're going to come in and circle this one as your solid. All right, let's do our next one. We have two products. We're supposed to figure out, do they dissolve? Are they aqueous, or do they not dissolve? Are they solid? We find the negative piece. If I find, here's my metal, this is the polyatomic ion, that's my negative piece, C2H3O2. I go find acetate. Acetate is right here. Acetate is in the aqueous soluble section. Is there an exception? No exception. So I write AQ for this one, aqueous. Then I look at my second compound. The anion of my second, the negative second part here, is Cl. I find Cl. Cl is in the aqueous section. I would write AQ, but I better check for exceptions. Cl is going to be aqueous, except if it's with silver. No. Mercury? No. Lead? Yes, it's with lead. Since I have an exception, I won't write AQ, I will write solid. So this one is my solid. And I would go ahead and box that in as my precipitate, because your precipitates are solid. Now, don't start thinking that always your second one is going to be the solid. That just is random chance. Let's do the next one. So we have two products, two ionic compounds. We have water all over the place. So we need to see, does our ionic compound dissolve? Look at your anion. Look at the second piece. Calcium carbonate. Carbonate is my second piece. I go find carbonate on the solubility table. Carbonate is in the solid section. Well, I'm going to write solid unless I have an exception. Carbonate should be solid unless it's with ammonia. No. It's with an alkali metal. Calcium is not an alkali metal. Alkali metals are this first column. Calcium is an alkaline earth metal, not the same thing, second column. So I don't have an exception. Therefore, I use the state of matter as shown. Insoluble is solid. That is your precipitate. Now let's look at our second compound, NaCl. Cl is the anion. So I find Cl. Cl, I should write aqueous, unless it's with silver, lead, or mercury. I don't have silver, lead, or mercury, so I write aqueous. That is not my precipitate. So I hope that helps. Good luck on your test.